A very good day to all of the panelists. My name is Yip Siew Ling, and this is a presentation of my final year project. The title is Anaerobic Digestion of Biogas Production from the Commercial Food Waste Sources and Countdown Inoculum, supervised by Dr. Jeefferie, BMFU Razak. For this presentation, the outlines are research background, problem statement, objective, scopes, literature review, methodology, result and discussion, and lastly, conclusion and future work. For the research background of this study, we can see in the figure 1, Malaysians produce 1.2 million tons of food waste with massive disposal which create bad impact to environment. For instance, food waste will contribute to the emission of greenhouse gases and lead to climate change. In the figure 2, biohydrogen from renewable sources will sustain the world power energy supply. It is potential as application to replace fossil fuels and consequently would not discharge greenhouse gases such as carbon dioxide. As we can see in the figure 3, biohydrogen production is considered costly due to the extensive setup and engineering requirements. This can be seen when the reactor design is huge in size and turns out into high cost in terms of investment. For the figure number 4, we can see, in Malaysia, cows that produce average 55 liters of cow dung per day would yield massive waste and consequently, the waste would harmful to the environment. For the problem statement of this study, as we can see in the figure 1, according to research, organic food waste account for 49% of trash in landfills, resulting in the production of a dangerous greenhouse gases known as methane, which contribute to global warming. To overcome these problems, food waste can be used to generate green energy and biohydrogen. However, up to now, conversion from food waste into optimum biohydrogen study is still difficult with low yield. In the figure 2, mini biohydrogen reactor design needs to be validated either it is feasible or not to produce hydrogen at a lab scale. Hence, parameters such as material for constructions and substrate consumption will be evaluated. In the figure 3, cow dung will produce dangerous greenhouse gases known as carbon dioxide, which contributes to greenhouse effect. This problem will be solved if turn cow dung into biofuel usage in the process of anaerobic digestion. There is 3 objectives in this study. For the first objective, it is characterizing the specific food waste, which is chicken leftover and rice leftover in terms of their compositions using Fourier transform infrared analysis (FTIR). Next, the second objective is to evaluate the effect of substrate chicken to rice leftover ratio with fixed content of inoculum during anaerobic digestion. For the third objective is to evaluate the potential of biohydrogen production based on reactor design and comparison study. There are a total of 6 scopes in this study. First is to determine the commercial food waste sources, which is chicken leftover and rice leftover in one popular fast food outlet in Inoculum, Malacca. Next is characterize the chemical composition of the chicken leftover and rice leftover through Fourier transform infra analysis. Next is design a mini reactor for digestion process, content of maximum 5 to 10 liter of substrate and inoculum. Then is to study the correlation of substrate, which is chicken to rice leftover ratio with fixed content of cow dung inoculum. Next is to analyze the biohydrogen gases by using gas chromatography thermal conductivity detector (GCTCD). For the 6th scope is to evaluate the potential of biohydrogen production through comparison study. For the chapter 2 literature review, there consists of 5 main chapters. The subchapter and the following citation is shown in the following bubble map. Same goes to second main chapter that named as anaerobic digestion. Third main chapter named as biogas generation, fourth main chapter named as reactor design, and the fifth main chapter that named as previous study related quantification. For the methodology in this study, there are introduction of methodology, food waste collection and feedstock preparations, biogas reactor design, and the output quantifications. This is the flowchart of methodology for this study, which involving the preparations and the experimentation works. At the beginning of the floor, the research will start food waste collections in one fast food outlet located at Gangsa, Malacca. After that, the feedstock is undergoing preparations by cleaning and drying methods. Next, the food waste will undergo characterization to determine their chemical compositions and through Fourier transform infra analysis. Next, design and fabrication of biogas digester tank will be carried out. After that, the testing stage for biohydrogen will be implementing. Lastly, the conclusion is made based from the analysis. For food waste collection and feedstock preparation, as we can see in the figure, the major ingredients of the food waste were chicken leftover and rice leftover. The chicken leftover was obtained from one popular fast food outlet in Gangsa, Malacca, 2 times per week. The method of collecting chicken leftover is through walk-in method. The chicken leftover, meat and bones were sorted out by myself from the garbage bag. Then, the chicken leftover was sorted out and the bone and the meat was separated accordingly. The separated meat from chicken leftover is then rinsed until it is clean. Until that, meats from chicken leftover were dried in the oven with 150 degrees Celsius for 40 minutes for 2 times. After that, dried chicken meat was grinded in the blender until it is become powder form. Rice leftover is collected from household and dried completely from the oven. Then, dry rice leftover is blended until turned into rice powder form by using blender. The cow dung inoculum is being collected in a cow farm at Betang Ulu, Malacca. I collected the cow dung into a 7 liters plastic bucket by myself by using a shovel. fresh cow dung was then left to fermented into 10 days and observed to appear in army green colors as shown. Lastly, substrate, which is chicken leftover and rice leftover, and the inoculum of cow dung were being inserted into the mini biogas reactor as shown. For the biogas mini reactor in this study, it is designed using Autodesk Inventor Pro 2020. There are a total of 12 parts of component in the biogas reactor as we can see at the figure shown. Biogas composition, which is biogas hydrogen in this study, was measured using gas chromatography thermal conductivity detector (GCTZD). GCTZD gas analysis was performed at the Material Characterization Lab of University Putra Malaysia UPM. There are a total of 3 results and discussion are generated based on the objectives stated in this study. The first finding is the FTIR analysis for the chemical composition of the chicken leftover waste and rice leftover waste. For the second finding is GCTZD gas analysis for chicken to rice ratio with fixed content of cow dung inoculum. The third finding is the potential of the biohydrogen production based on mini reactor design and comparison study. For the Fourier transform infraspectroscopy of chicken leftover waste, there are a total of 4 peaks found in this sample, which is carbohydrate peak, protein peak, fat peak, and water peak. The carbohydrate peak is ranged between the wavelength of 1045 to 1053. Mordor Chai, 2001, reported that the carbohydrate structure is carbon to oxygen stretching coupled with carbon to oxygen bending. For the second peak, it ranged between the wavelength of 1517 to 1652. The chemical component for this peak was found as a protein peak and consists of amide 1 and amide 2 as structure. This is according to Skurt and Baranska, 2007. Next, for the fat peak that located at a wavelength of 2853 to 2859, Young, 2015, state that there is asymmetric CH2 stretching mode as its structure. Last but not least, there is the presence of water component in this chicken leftover waste at a wavelength of 3273 to 3293. Skurt and Baranska, 2007, reported that there are the presence of stretching O to H symmetry structure inside the water component. For the Fourier transform infraspectroscopy of rice leftover waste, there are a total of 4 peaks found in this sample, which is carbohydrate peak, protein peak, fat peak, and water peak. According to Mordechai 2001, for the carbohydrate peak that range between the wavelength of 1045 and to 1053, there are the presence of C to O to C stretching structure that contain of nucleic acid and phospholipids. For the second peak is protein peak that range between the wavelength of 1517 to 1652. Baranska 2007 state that there are present of carbon-oxygen bond and stretching carbon-to-carbon bond uracil in this protein peak. On the other hand, Young 2005 reported that the chemical component for fat is located at a wavelength of 2853 to 2859 and contain asymmetric stretching mode of the methyl group as its chemical structure. For the wavelength range from 3273 to 3293, Skurt 2007 state that there are present of fat peak and consists of stretching OH symmetry structure inside the water component. In accordance to figure 3, it's shown the overlay of rice leftover waste, chicken leftover waste, and the mixture of 1 to 2 between chicken leftover waste and rice leftover waste. It was found from the spectroscopy. For the rice leftover, there are 4 dominant significant peaks, which is carbohydrate peak, protein peak, fat peak, and water peak. Same goes to the chicken leftover waste and the mixture of 1 to 2 between chicken leftover waste and rice leftover waste. The CO stretching coupled with CO bending of the C to OH of carbohydrate at 1045 to 1053 was assigned to carbohydrate peak. The stronger relative intensity of the mixture of 1 to 2 between the chicken leftover waste and rice leftover waste indicate that higher carbohydrate content than rice leftover waste and chicken leftover waste. According to Pawan Kumar, 2011, this is due to the presence of glucose that belongs to carbohydrates. Glucose as a molecule will bond with another glucose to form carbohydrates. Baranski, 2007, stated that the absorption peaks at the wavelength of 1517 to 1652 is resulted from stretching C to C stretch of phenyl that associate with amide 1 with amide 2 of protein. For the fat components in the samples, Young 2002 reported that the absorption band at 2853 to 2959 were ascribed to methylene of lipids in membrane lipids. On the other hand, according to Dovesco, 2000, there are presence of water content in the wavelength of 3273 to 3293 that consists of stretching OH symmetry chemical structure. From this result, we can say that gas detection can be detected through the presence of peak in the chicken to rice ratio of ratio 1 to 2. There are a total of 4 gases is being detected in this sample, which is hydrogen gas, oxygen gas, nitrogen gas, and carbon dioxide gas. The hydrogen gas are considered as the fastest gas that has been detected by thermal conductivity detector. This can be seen at the area of retention for 5.1 minutes. Hydrogen gases are the gases that appear the fastest compared to the other gas. The area of the peak of the particular retention time is 21.124. At the area of retention for 7.629 minutes, oxygen gases has detected. The area of the particular retention time is 4.4248. Then, for the nitrogen gas, is being detected at the area of retention for 7.786 minutes. The area of that particular retention time is 133.02547, which ranked the first as the most gases detected by the gas chromatography thermal conductivity detector GCTCD. On the other hand, carbon dioxide is being detected at the area of retention for 14.774 minutes. The area of that particular retention time is 32.20571. For the first sample, which is the mixture of 1-to-1 between chicken leftover waste and rice leftover waste, they are present of three gases, which is nitrogen gases, oxygen gases, and carbon dioxide gases. There is high amount of nitrogen gases present in this sample, as the area of peaks is up to 76.8%. This is followed by the oxygen gases that have 19.1% and the carbon dioxide gases of 4.03%. For the second sample, which is the mixture of 1-to-2 between chicken leftover waste and rice leftover waste, we can see there are four types of gases is detected, which are hydrogen gases, nitrogen gases, oxygen gases, and carbon dioxide gases. Nitrogen gases still have the largest amount in this sample, which gather up the total area of peaks up to 69.3%, and followed by the second highest of peak, carbon dioxide gases that have 16.5%. In contrast, both hydrogen gases and oxygen gases have a relatively low content of its compound, which is 10.8% and 3.2% respectively. For the third sample, which is the mixture of 2-to-1 between chicken leftover waste and rice leftover waste, there are three gases is being detected, which is hydrogen gases, nitrogen gases, and carbon dioxide gases. Nitrogen contain the highest percentage for the area of peaks, which is 88.0%, and followed by carbon dioxide gases that contain of 8.7% for the area of peaks. In contrast, percentage for the area of peaks of hydrogen is relatively low. There is 3.2 out of 100%. Based on our design, we found that the hydrogen is detected, hence our design is found to be potential at the ends. However, one of the tested sample is not detected hydrogen due to the ratio of 1 for chicken leftover waste and ratio of 1 for rice leftover waste. Ley 2003 reported that for the biohydrogen production, potential of carbohydrate-rich solid waste was approximately 20 times higher than fat and protein-rich one. Thus, due to the content of chicken leftover waste and rice leftover waste in the ratio of 1-to-1, with fixed content of cow dung inoculum, is not enough to generate hydrogen at this position of ratio. In contrast, the mixture of 1-to-2 between chicken leftover waste and rice leftover waste is able to yield 10.8% of hydrogen gases as detected from GCTCD gas analysis. In the report, I also include the comparison study truth literature survey on the potential of biohydrogen. The deliver of reported content can be checked in my thesis. For the first outcome, FTIR analysis was successfully performed to analyze the composition of chicken leftover waste and rice leftover waste. Through this analysis, I am able to understand the nature of chemical composition of substrate used for biohydrogen production. Hence, objective 1 is achieved in this study. For the second outcome, the collected gases from chicken to rice ratio 1-to-1, 1-to-2, and 2-to-1 were evaluated through GCTCD testing. Through the testing, it was found that ratio 2-to-1 promotes higher possibility of biohydrogen production. Thus, objective 2 is achieved in this study. For the third outcome, the biogas reactor was found workable and potential as there is presence of biohydrogen gases from the GCTCD gas analysis. Other than that, comparison study with other existing system and design has successfully made in this study. Hence, objective 3 is successfully achieved in this study. In this study, it is recommended to increase the retention time, HRT, for anaerobic digestion and quantify the energy content of feedstock using bone calorimeter. Other than that, repeat the GCTCD testing for 6 times for better accuracy and evaluate the effect of varying inoculum content in biohydrogen production. Thank you for your attention.